Let us begin by reading the word problem aloud. Marissa wants to place an online order from her favorite clothing website. She really likes 27 articles of clothing, but 16 of these are unavailable in her size. How many articles of clothing can she actually buy? So let us begin our strategy for problem solving by analyzing the problem. That is, let's see what information we can extract. So now let's go ahead and identify what it is we want to find, or what question it is we want to answer. So in this case, the question that we want to answer is, how many articles of clothing can she actually buy? So once we have determined the question that we want to answer, we're going to know what it is exactly our variable is going to represent. So let us go ahead and assign a variable, and again, we could use any letter in the alphabet. We'll go ahead and use the variable x. So in this case, x is going to equal the amount of articles of clothing that Marissa can actually buy. And that came directly from the question, how many articles of clothing can she actually buy? So again, it's basically the question reworded in the form of a statement, and that is our assigning of the variable. So now let us begin forming our equation. Before forming the equation, we want to see what other information is very useful in the word problem. So let's see what else we can extract from here. So we know Marissa wants to place an online order from her favorite clothing website. And we know that she really likes 27 articles of clothing. The only problem is that 16 of these are unavailable in her size. And from that, we want to determine how many articles of clothing she can actually buy. So our equation is going to be the number of articles of clothing she really likes. So she really likes 27, but 16 of those are unavailable in her size. So of those 27, she cannot buy 16, so we're going to have to subtract that number from 27. And what's that going to be equal to? Well, that's going to be the amount of articles of clothing that Marissa can actually buy, which is our variable x. So now let's talk about this in a real world scenario. Suppose you go to the store and you like 27 articles of clothing. However, 16 of those are unavailable in your size. So we're going to have to subtract 16 from the 27, because the new number of articles of clothing that you can actually buy decreased. So therefore, the numbers that you can actually buy is going to be our variable x. So this actually does make sense in a real life situation. So that's an indicator that our equation is the correct equation for this problem. So now let's go ahead and solve the equation. So again, when solving an equation, you want to start off with the original problem, or the original equation found in step 3. So 27 minus 16 is equal to x. All we need to do in this problem is simplify the left-hand side of the equation, 27 minus 16. That is, of course, because our x variable is already completely isolated on the right-hand side. So let's go ahead and do so. So off to the side, we'll do 27 minus 16. So we'll do 7 minus 6. That's going to give us 1. And then we'll do 2 minus 1. It's going to give us 1 as well. So then 27 minus 16 is 11. We'll simply bring down the x. So therefore, in this problem, x is equal to 11. So let us state our conclusion clearly. Therefore, Marissa can buy 11 articles of clothing. So remember, the question was, how many articles of clothing can she actually buy? And our conclusion is that Marissa can buy 11 articles of clothing. So again, our conclusion is simply the question reworded in the form of a statement. So now let's go ahead and check the result. For this problem, for any problem, if you want to check the result, we always want to start off with the original equation found in step 3. So that's going to be 27 minus 16 is equal to x. However, we now know that x is equal to 11. So all we need to do is simplify the left-hand side, 27 minus 16. Luckily for us, we already did that. And now we know that 27 minus 16 is equal to 11. So we end up with 11 equals 11. That is indeed a true statement. So our solution is correct.